In this video, we'll continue our discussion by deriving the half-angle formulas. So the next set of identities is the set of half-angle identities, formulas. We can derive this. I'm going to show you exactly how to do this. This is a formula that we just derived in the last video. So what we can do to derive a half-angle, what we're going to do is let theta, and I'm going to call this alpha over 2. That's a half, right? Taking half of it. I'm going to go ahead and replace all this, or my theta, with half. So I got 1 minus cosine times 2 times alpha over 2 over 2. All right, well, that ends up just being, I'm going to rewrite the left side, alpha over 2. And then we get 1 minus, and notice we're going to have cosine of alpha over 2. This isn't where I want it, though. I would like to have sine of alpha over 2 equals something, so I need to get rid of that square. So I get sine of alpha over 2. And I'm going to take the square root, but when I take the square root, I have to introduce a plus or minus. That's from PreCalc 1. So we get sine alpha over 2 is equal to plus or minus the square root of 1 minus cosine alpha over 2. That's our formula. I could do this with cosine and tangent. I'm only going to do it here for sine because it's the same kind of reasoning. I'll let you guys go through that. But here are my 3 formulas, and you can see that they are very similar to... cosine is very similar to sine in that same way that we would solve, and tangent as well, seeing that inside. Now, notice, though, we get 2 other formulas. I'm not going to derive those for you, but this formula and that formula are very nice because they don't involve a plus or minus, and they don't involve a square root. So keep those in mind. Know those exist for half angles. Let's get some examples in. All right, so they want us to do... given that tangent alpha, I like to write things down, tangent alpha is 8 over 15, and then we're in quadrant 3. Okay, so for 1, sine of alpha over 2, and we're going to use this exact formula that we just used. This is going to be a plus or minus, and we'll deal with that here in a moment. And then the formula that we just came up with was 1 minus cosine alpha over 2. Okay, notice we don't have a cosine to use, but I do have this tangent, and I have that it's in quadrant 3. So what I'm going to do is anytime they give me this information is I'm going to draw it in that quadrant. So here's my right triangle. It's in that quadrant, and then alpha is here, and we have tangent, which is 8 over 15, and since they're both in that quadrant, they both have to be negative. And we have to figure out what goes on that hypotenuse. So that's going to be 8 squared, which is 64, plus 15 squared, which is 225. That gets me a 289, which tells me if I take that square root, I get a 17 there. So I found all of my triangle here, and now I can use this to answer my stuff. Okay, I got plus or minus the square root of 1 minus cosine. Okay, I can go ahead and replace cosine alpha because I have my triangle. It's going to be negative 15 over 17 over 2. Okay, I also know that I'm trying to find sine. So to deal with the plus or minus, and I'm in quadrant 3, sine must be negative because sine is y. All right, now I'm going to fill in that. I got 1 plus 15 over 17 over 2. And I'm going to do that in my calculator out of laziness. So I got 1 plus 15 seventeenths. Right, enter. And then I'm going to divide that by 2, enter, and then change that back to a fraction. Hopefully it will become one. It is 16 seventeenths, so this is equal to negative the square root of 16 over 17. What your homework is probably going to want you to do is this, negative square root of 16 over the square root of 17, which is negative 4 over the square root of 17. And then they're going to want you to rationalize. So they're going to want you to multiply top and bottom by the square root of 17. So we get negative 4 square roots of 17 over 17. So again, this is just using the formula that was given. And then we had to just work it all out. That's all it was. But the cosine came from drawing our triangle. Now, the good thing is this now will help us figure out the rest. Okay, cosine of alpha over 2. That's going to be equal to plus or minus the square root of, and I think this one, I hate that it does that. I think it's 1 plus. I'm going to go check to make sure. It is 1 plus. So 1 plus cosine of alpha over 2. And now I just use that same number that we had. I know that it's going to be negative because cosine is left. It's in quadrant 3. And I get 1 plus 15/17 this time over 2. So I'm going to use the formula again. 1 plus 15/17, enter, divided by 2, enter. Then I'm going to use math frac to get me back to a fraction. So I get minus square root of 16/17, and we could see this is going to spit out the exact same thing. Now I'm curious, did I accidentally? Ooh, and I wonder if I think there's actually supposed to be a minus here. Let's double check, or did I lose it? Oh, I made a mistake here. Okay, so be careful, because this formula is, it is 1 plus, but my cosine is actually negative 15/17. So there we go, 1 minus 15. I was like, why did we get the same answer? 1 minus 15/17, enter, divide by 2, and then change it to a fraction. So this time I get negative square root of 1/17. It's probably going to want you to rationalize. I can see that it's going to work out the same way, just without that 4. All right, so there's cosine. And then now they want us to do tangent of that angle. I would not use the formula in this case. What I would do, you could if you wanted, but it's nasty, so I'm going to do this instead. Sine of alpha over cosine of alpha, alpha over 2. We already have those values, so I can just plug them in. I'm going to, I guess we could just use, I'm going to use this number because I'm going to plug it all in anyway. And then we get negative 1 over the square root of 17. That's this number here. If I were to take the square root of 1, you can see that the square root of 17s are going to cancel, and I'm just going to get a 4 over 1, which is our 4. All right, I think that's much easier than using the tangent formula. You're more than welcome to. It works just it works just the same way. But I think this is less work.